In this video, I would like to share an easy approach for remembering the confusion matrix and deriving the true positive rate and the false positive rate and various other metrics from the confusion matrix. These metrics are used for describing the performance of classification models on test data, primarily for binary classification problems. The very first step would be to decide the axes on which I would like the actual and the predicted values to be organized, and then using this approach as a standard approach for deriving the metrics. By this, I mean that I choose to organize my confusion matrix display in such a way that the row levels contain the actual class labels and the column levels contain the predicted class labels, and I organize my matrix in this way every time I want to derive the metrics, regardless of the output by any software. This is optional but convenient for having a standardized approach for deriving the metrics. So let's create a confusion matrix with binary class labels yes, no, and values x, y, a, and b. The easiest metric to identify are the true positives and the true negatives. These are the labels which are correctly predicted by our classifier as true and false and are used for determining the accuracy of the model. Next in line are the false positives and the false negatives. So, an easy way I remember the false positives is by writing false positives but should have been negative. So let's look at the confusion matrix here. Now let's sort of break down the explanation and try to map the false positive value. Now the line says falsely predicted positives but should have actually been negative. So the true value should be negative or no, but it's been predicted as positive or yes. This would correspond to A. Basically, just by adding the additional statement to my understanding, I can easily remember the right way to derive false positives. The next is false negatives. Like the case above, this time I will write false negatives but should have been positive. On slowly repeating the sentence, I understand that the value should have been positive or true but was falsely predicted as negative or false, and this would correspond to Y. So just by completing the sentence using opposite words, I can retain my understanding of false positives and false negatives. Now let's go a step further and derive other metrics and understand their interpretation. The easiest ones are accuracy and misclassification rate. Accuracy is simply the percentage of correct values predicted by the model. The correct values predicted are the true positives and the true negatives, and thus the percentage would be upon the total of everything, and thus the formula for accuracy will be true positives plus true negatives upon the true positives, true negatives, false positives, and false negatives. Similarly, misclassification rate is the percentage of incorrect values predicted by the model or values which are misclassified. These values are the false positives and the false negatives, and we divide the sum of these values over the total of everything. Thus, the formula for misclassification rate is false positives plus false negatives upon the true positives, the true negatives, the false positives, and the false negatives. Now let's take each of these metrics and determine the rate, or rather the percentage, from the confusion matrix. The first one we will pick up is the true positive rate or the true positive percentage. An easy way to remember this is that when we talk about the true positive rate or the true positive percentage, the percentage needs to have a base or a total of something, just like in the case of accuracy and misclassification rate above, and intuitively to calculate the true positive percentage, the base should be the total number of positives or yeses in our case. Thus, you want to calculate the true positives over the total positives, and that would be the summation of both x and y because they are the true or the correct positives for this model. Thus, the true positive rate is simply true positives upon total actual positives, which is the true positives upon the true positives plus false negatives, or true positives upon x plus y. We have just successfully derived the true positive rate, and using a similar ideology, we will derive the rates for the other three metrics. Another good thing to know is that the true positive rate, not the true positives, but the true positive rate is also known as sensitivity or recall. Similarly, to calculate the true negative rate, we would use the true negatives and divide them by the total number of actual negatives. In this case, that would end up being b divided by a plus b, or true negatives divided by the true negatives plus false positives. This metric is also known as specificity. Next, we have the false positive rate, which is the total number of false positives divided by the total negatives. Remember, false positives but should have been negative. And this is because we're calculating the false positive rate. So we're finding the falsely predictive positives which should have been negative, and thus we divide the false positives by the true negatives, which would be a upon a plus b, or the false positives upon the false positives plus true negatives. This is also known as type 1 error. Lastly, we have the false negative rate, and this is the false negatives over the actual number of positives, and therefore y upon x plus y, or false negatives upon false negatives plus true positives. This is also known as the type 2 error. At this point, we have derived almost all the metrics by using simple strategies to remember the terms and by focusing on one metric at a time. You could do the same even if you inverted the axes of the actual and the predicted values by having the predicted values organized in the x direction. The logic for deriving the metrics would be the same, however, you would just be looking at the confusion matrix in a different way. The very last metric we want to derive is precision. Precision is the ratio of correctly predicted positive values divided by the total predicted positive values. Basically, it is a measure of how good our model is at predicting true positives. The cue to remember this are the letters PRE. So basically, when we talk about precision, we talk about the predicted column and the positive values in the predicted column. Therefore, precision is x divided by x plus a, or true positives upon the true positives plus false positives. The precision for simplicity is also known as the positive predicted value. We similarly have a metric called the NPV, or the negative predicted value, which is b upon b plus y, or true negatives upon true negatives plus false negatives. Before closing, I just want to mention that in the ROC curve we plot the true positive rate versus false positive rate, or sensitivity versus 1 minus specificity, where 1 minus specificity is used for deriving the false positive rate using specificity. These are all the metrics I'm going to cover in this video. Thank you for your time. Also, all the written content here is saved to my GitHub page as PDF for reference, and the link is mentioned in the description below. Thank you.